All right, so today we're going to talk about death investigation, what a medical examiner or coroner does. And we'll spend a couple days on this, just different ways to determine how long someone has been dead and why they died. So, what are some of the functions of a medical examiner or coroner? The first thing we need to say is that a medical examiner is a medical professional, whereas a coroner may be an elected official that doesn't have medical background. That's just the way that things are still done in this country. In smaller places where you may not have a doctor that you can dedicate to doing like cause of death determination. So, what is either way, whether you have a medical examiner or coroner, what are they responsible for? First thing is the death scene. They're the boss of the entire crime scene anywhere a death has occurred, assuming that it's potentially a crime. They are, of course, in charge of the dead person. The CSIs we've already talked about don't really touch the dead person. You don't always use a medical examiner or coroner, though. So there are some cases where you don't. But what cases would you definitely bring in a medical examiner? If the person apparently died by violent or traumatic means, whether it was a homicide apparently or an accident or whatever, if it was violent or traumatic, they're going to bring in a death investigator, a medical examiner. If it happens in public outside of the hospital, that's typically suspicious. And then if in Missouri, the threshold is 17. So anywhere in Missouri, if someone dies under the age of 17, even if it doesn't seem to be suspicious, if it seems to be by natural causes, they will bring in a coroner or medical examiner just to make sure. If it is sudden or unexplained, even if it's not violent or traumatic, they will usually bring in a medical examiner. Or if there's a contagious disease involved, because they want to make sure that they get that body quarantined and so that it doesn't spread disease. All right, so some of the functions of a coroner or medical examiner would be to secure the scene. We want to make sure that the crime scene doesn't get contaminated. To validate death, make sure the person is in fact actually deceased. And then also to identify the victim, which can go wrong sometimes. The case of Whitney Serac and Laura Van Ryn happened in 2006. They got into a car accident together. They were friends. But because of injuries and swelling and things like that, Whitney Serac, who lived, was originally believed to be her friend Laura Van Ryn because Laura's purse was next to Whitney. So Laura actually died, but Laura's parents sat vigil next to Whitney in the hospital for 5 weeks before the swelling subsided and she was identifiable, and she essentially woke up and they realized who she actually was. So identification of the victim can be done by, an ID in their pocket, a phone in their pocket, whatever, in the cases of, extreme injury, but sometimes it does go wrong. The other important jobs to determine cause of death. So this would be what kind of injury caused the death, whether it was stabbing, shooting, fall from a height. Mechanism, this is the physiological way that somebody died, so it's going to sound very technical. Rather than just stabbing, it might be exsanguination, which just means bleeding to death. And then the manner of death. This is very important because the manner of death, once it's determined, it decides whether we're going to treat this as a crime scene. So if the coroner or medical examiner says that this was natural causes, and it turns out the person was poisoned, because it was originally ruled natural causes, you're going to lose a lot of evidence as the EMTs come in to collect the body and step all over the scene and move things around. So it's very important that they get this right off the bat. So here's an example. Someone dies from massive hemorrhage due to a gunshot wound through the head as a result of accidentally dropping a gun and it discharging. So you can see the color coding there shows us that the massive hemorrhage, which is a very biological sort of doctor term for, bleeding, extreme bleeding. And so that would be considered our mechanism. Gunshot wound would be like the injury, and it's a lot more sort of layman sounding, very common sounding, and that's our cause. And then the fact that it was an accident is the manner of death. So again, once you decide it's an accident, we're going to stop treating it as a crime scene. And if you were wrong and it turns out that it was a homicide, you will have lost a lot of evidence, and it's going to be very difficult to convict somebody. Here's another example. You can maybe pause and think about this one. So after being stabbed by his neighbor, a man died from exsanguination, which is extreme blood loss. So see if you can identify the cause, the mechanism, and the manner. Okay, so the mechanism should be pretty easy to pick out because it's a really technical sounding term, and that's exsanguination, right? So extreme blood loss, that would be our mechanism. That's our physiological technical term. The stabbing would be our cause. That's the actual injury or reason. And then the fact that it was his neighbor stabbing him means that this is going to be treated as a homicide. So that's that's our manner of death, homicide. Okay, the last thing we're going to talk about is determining post-mortem interval. Essentially, how long has a person been dead? We'll talk about time of death a little bit later. We're going to focus on post-mortem interval, or PMI, first. There are a couple different methods. One is using body temperature, which we're going to talk about today. We are warm-blooded, so as soon as our chemical reactions in our bodies stop happening, we're going to start cooling off, and that happens pretty much at the moment of death. So we begin to cool off. Rigor mortis is muscle rigidity, or how stiff the muscles are. That can be useful because the process of stiffening and then loosening happens at a pretty predictable rate. Livor mortis is discoloration due to blood gathering under the skin, and we'll talk in more detail about that later on. And then finally, entomology. This is where we use insect larvae, specifically usually fly larvae, to determine how long a body has been deceased. So let's focus in on algor mortis, body temperature. So first things we need to establish: the temperature is usually taken in the liver because we don't have to worry about injuring the person anymore. And it is a very central part of the body, so the temperature change is pretty gradual and predictable. All right, some assumptions. First, we're going to start with the initial temperature, TI, is 98.6 degrees Fahrenheit. Now, that's a big assumption. That is not everybody's baseline body temperature, but we should be pretty close to that with most people. Another assumption is that the body will cool under normal conditions, and we'll talk more detail about that later, under normal conditions at about 1.4 degrees Fahrenheit per hour for the first 12 hours. So that is how fast most bodies will cool, roughly. After 12 hours, it's going to cool a little slower because it's not as hot anymore. So that transfer of heat is going to be a little slower at about 0.7 degrees Fahrenheit per hour. And if you're wondering how accurate that is, it doesn't really make sense that there would simply be two different rates of cooling. And yes, you're right. It is actually not just two rates. It's more gradual. But this allows us to do some simple calculations and get a pretty close approximation to how long someone has been deceased. Okay, so we're going to do some problems here in a second. And before we get started with that, one assumption here that for the first 12 hours, a body cools at 1.4 degrees Fahrenheit per hour for 12 hours. That results in a drop in temperature of 16.8 degrees Fahrenheit. Now that can really simplify some of our problems, because that means that if a body has been cooling for 12 hours, at 12 hours, starting at 98.6, it will have dropped by 16.8 degrees, and it will be 81.8 degrees Fahrenheit. The reason that's important, and the reason that makes our lives easier, is because above 81.8 degrees Fahrenheit means that that body has not been dead for more than 12 hours, and so we don't have to worry about this second rate of 0.7 degrees Fahrenheit per hour. If it's below 81.8, then we have to worry about a second rate of cooling. So let's take a look at what we're talking about here. So we'll go through two examples. The first one is going to be, what if we haven't reached 81.8 degrees Fahrenheit yet? So here's the problem. Estimate the postmortem interval for a body that's found at 92 degrees Fahrenheit. We'll repeat our assumptions. You don't have to write them down. You've already written them down. but how long has that person been dead if their body is found at 92? So the first step, figure out the change in temperature. So they started at 98.6, we're assuming, and now they're at 92. So it's just a subtraction problem. So it gives us 6.6 degrees Fahrenheit. Second step, if they've dropped by 6.6 degrees Fahrenheit at a rate of 1.4 degrees per hour, how many hours has that been? Well, that's just division. 6.6 divided by 1.4 gives us 4.7 hours. And then, because we don't talk about hours in terms of decimals, we want to convert that 0.7 into minutes, which simply means multiplying by 60. 60 minutes in an hour. So 0.7 hours should be about 42 minutes. Hopefully that makes sense. And then the last step is just to put the 4 hours together with the 42 minutes. And this person has been deceased for 4 hours and 42 minutes. Okay. What if it is less than 81.8? What if we find the body at a lower temperature? Let's say 78.8. Well, we know that it's been dead for at least 12 hours because it's below 81.8, right? So we need to figure out how much beyond 12 hours that person, or how far beyond 12 hours that person has been deceased. So this time we're going to just assume that it's been 12 hours and say, okay, it's going to be 12 plus some more hours after that. Hopefully that makes sense. So we're not going to worry about starting at 98.6. When we do our delta T this time, we're going to start at 81.8 because we already know that any body at 12 hours should be 81.8 degrees Fahrenheit. So what I want to know is how far below 81.8 am I? And the answer is, in this case, exactly 3 degrees. So if we, this time we're going to divide by 0.7 because again, we're going at a slower rate of cooling after 12 hours. So that looks like this, 3.0 divided by 0.7, and that is going to give us 4.3 hours. Add 12 hours, right? Because we, that's how we got down to 81.8 in the first place, right? We had to allow 12 hours to pass to get to 81.8, so we got to add that back on. So it's not that this person has been dead for 4.3 hours. They've been dead for 4.3 hours plus the initial 12. So they have been dead for 16.3 hours. And then, of course, the rest is the same. Convert decimals into minutes. So 18 minutes. So this person has been deceased for 16 hours and 18 minutes. And we'll talk later on about how this may not be completely accurate, but it gives us a pretty good estimation.